Okay. What if you give in an element like nitrogen? Atomic number 7. Now we're going to follow a rule called the what? The Hund's rule. The Hund's rule, it says that you have to fill the orbitals of a particular sublevel where there are options. You have to fill them singly first before pairing will occur. Now, so for example, I'm going to ask you a question. How many unpaired electrons are there in nitrogen? How many unpaired electrons are there in nitrogen? So it's until you know the electronic configuration that you'll be able to tell us how many unpaired electrons. So let's see how we're going to fill this. I'm going to use our box. Now, remember we say an orbital is represented by a box who represent a region of space where the probability of finding an electron is highest. So now, for nitrogen, I'm going to have 1s2, 2s2, 2p3. Now, for you to know the number of valence, number of unpaired electrons, you have to represent them like this. We're going to represent them with a box. This 1s, 2s. Remember the p orbital has 3 orbitals. 1, 2, 3. So this is going to be 1s, 2s, and 2p. Where this is going to be what? Px, py, and pz. Now, 1s has 2 electrons. 2s has 2 electrons. So these are the 4 electrons. But the 2p has 3 electrons, which you can feel like this. But Hund's rule is saying no. You first of all do what? Fill them singly first. So here will be 1, 2, 3. And these are the 3 electrons in the p orbital. So if there is an extra electron, like in the case of oxygen, it will come in here. But since it is only 7, he said what will happen? You fill them singly first before pairing will occur. So to answer this question, how many unpaired electrons are there in nitrogen? We can now say that there are what? 3 unpaired electrons. If you find this interesting and you are learning really, please like this video, leave your question in the comment section, share the video, and give me a follow for more example on A-level electronic configuration.